Now we're going to do something that's a little different. We're going to go from weight percent to formula. Does this happen in the real world? All the time. How so? Sometimes we get products from the field, and it's very easy to get these numbers. An analytical chemist can get these numbers very easily. And oftentimes it happened, and in the real world, when I used to work, I would be given just a black blob of stuff, just some gunk. And they would say, hey, what is this? Well, first thing I would do is send it to analytical, and they would tell me what the weight percent of each species was. And then I would do the calculation I'm going to show you now to get the formula. So, again, this is just not the type of problem that somebody invented just to make chemistry hard. This is the kind of stuff that's done in the real world. This first step, when we need to order raw material, we need to order by weights. The second one is when we have weight percents, when we have a sample analyzed from the field, we need to determine what the material was. Okay, so here we go. So now I want you to pretend we didn't do that first part and pretend we're just starting out with a problem that says a compound is 5.9% hydrogen and 94.1% oxygen. What is its empirical formula? To get to the formula, to get to moles, we have to first get to grams. So how can I convert a percent to grams? There's one very easy trick you can do. I'm just going to assume I have a 100-gram sample. And I can do that with this. Why? Because the formula doesn't change no matter how many grams I have. Right? The formula for water is the same whether you have 1 ounce or an ocean full. So the answer we get is not dependent on the amount of material there. So to make my math really easy, I'm going to assume I have a 100-gram sample. So if I have a 100-gram sample, 5.9% is how many grams? Just 5.9. And if I have a 100-gram sample, 94.1% of 100 is what? 94.1. So here's my trick that people that don't listen to this may struggle mightily with this. But here's the trick here. We're just going to change this percent sign to a G, and that gets you through the first step. Now I need to go from what? Grams to moles. And then I have the formulas. So let's see what we have. I know I have 5.9 grams of hydrogen. I know from the periodic chart, for every 1 gram of hydrogen, there's 1 mole of hydrogen. So when I multiply that out, I wind up with 5.9 moles of hydrogen. How many moles of oxygen do I have? Well, let's see. I have 94.1 grams of oxygen, but I know there's 16 grams of oxygen for every 1 mole of oxygen, and I wind up with 5.9 moles of oxygen. So what's my new formula? Well, it's kind of weird right now. Let's just write it. So I have H 5.9. Yep. And I've got O 5.9. Well, you can't do that, right? You can't do that. Formulas have to be what? Whole integers. So now you need to learn a math trick. It's not so much chemistry, it's a math trick. And it's going to be this. Divide by and times. When you pull this formula together, you're rarely ever going to get exactly the right numbers. You're going to get some weird numbers. So here's what you're going to do. The first thing is divide by. That's the first thing. And then if that doesn't get us to a formula, then we're going to do a multiply trick. Okay, so you're going to always need to divide, but you might need to multiply also. So let's see. Divide through by what? Divide through by the smallest one of these. What do we have here, though? It just so happens both of these are 5.9. 5.9 divided by 5.9 is 1. 5.9 divided by 1 is 1. So our empirical formula is HO. Okay, that's not a real chemical species. So sometimes the empirical formula represents a real chemical species, and sometimes it is a hypothetical one. So your formula is HO. That's the second type of problem. Now let's flesh out this math thing again. Let's do a couple and see what you would do if you needed to multiply. Let's take this formula right here. Let's say X wound up being 1.5. Okay, so just so you understand where I'm done. We've done our divide by step. And H turned out to be 1 and X turned out to be 1.5. Now how am I going to get rid of that? I've got to make both of these whole numbers. This is where your multiply trick comes in. It's if you do your divide by trick, if everything's not integers, whatever's not a 1, you have to multiply it out. Okay, we'll take a wild hairy guess what I'm going to need to multiply by 2. So if I multiply this by 2, I get H2X3. Okay. How did I know to multiply by 2? Well, I have to keep picking numbers until this goes to some integer. Okay. Now let me tell you how I could look and see that it needed to be 2. What I do is I just focus on this fraction here. I'm just going to focus on that fraction. And it's what? 0.5. It's a half. Yep. So just picture this as currency. 50 cents. If I've got 50 cents, how do I get to the nearest dollar? I would multiply it by 2 to get rid of that fraction. Yes? So look at this as being the pennies. Look at this as being dollars, that first number, and everything on the other side. Look at it as being pennies or currency. $0.5. $0.5, 50 cents. 50 cents times 2, that's how I knew. So let's do another one and show you how easy this logic is. Okay, let's do another one. And let's say now, maybe I'll pick a different color. Now, instead of 1.5, let's say we did this. And we got something really close to 1.33. Remember, whatever this number was, we divided through by the smallest one. And one of these goes to 1 and the other one is not an integer. So guess what I probably need to multiply by? 3. Why? Because I'm going to do just my dollar thing again. So what do I have? 33 cents. How many units of 33 do I need to make a dollar? 3. So I'm going to multiply by that 3. What's my answer going to be? H3X4. Yes? 0.33 times 3 is 1. And then I had to also multiply this 1 by 3, so I get 4. Okay, let's do one more, and then I'll give you an easier way if you're not following this. So let's say the next one is H1X1.25. Okay, 1.25. So what do I have? I have what looks like about a 0.25. That would remind me of about a quarter. So how many quarters do I need to make a dollar? 4. So this is going to go to what? H4X5. And that's how you do it. If you cannot do that, so let me tell you what the standard way would be. Anytime one of these is 1 and all the other ones are larger than 1, if you want to do this by trial and error, you multiply everything by 2. If that doesn't give everything whole numbers, multiply it by 3. If that doesn't work, multiply everything by 4. If that doesn't work, multiply it by 5, then 6, then 7, then 8, then 9. One of those mathematically has to work. One of those will work. It's easier if you can look and guess at what it's going to be, but one of those has to work. But within 10% error, we're going to accept the little error. So here's what you need to know when you multiply these out. If your answer is within 0.1, then you go ahead and round it to the next digit. For example, let's say I had 1.30 here. So if I multiply by a number that gets me very close to integers, in this case the number 3, I get H1X3.9. Notice, this number is within 1/10 of the next integer, so you would call this 4. If this were 3.8, you would have to find a different number to multiply it by. But since this is 3.9, this meets our 10% rule. Does that make sense? So this would now be 4. You're within 10%, 0.1 of a whole number. And the same thing would be true if this were 3.1. You would just round that to 3. In short, if the number ends in a 0.9 or it ends in a 0.1, just round it to the nearest integer. If it ends in any other thing besides a 0.9 or a 0.1, then you need to do your multiplication and find out what the nearest whole number is.